Hey guys, how you doing? This is Mr. Chavla, and I'm going over the August 2016 Common Core Algebra 2 exam. And in this section, I'm going to be going over part 3, that's numbers 33 through 36. All right, we're starting to wrap this thing up. And again, it's Mr. Chavla or Mr. C. Going over number 33 through 36, the part 3 questions of the August 2016 Common Core Algebra 2 exam. These were the 4-point questions. Let's go ahead and get started, okay? I actually liked number 33. Okay, so I'm going to make this window a little bit smaller so I'm not blocking everything. So the first part said to find algebraically the zeros of p of x, where p of x is equal to x cubed plus x squared minus 4x minus 4. So the first thing I'm going to do, guys, is I'm going to, I need to minimize me right now. What I'm going to do is, when I say to find the zeros, you're setting the equation equal to 0, right? We're going to use a method called factor by grouping. So I'm going to factor this part first, and then I'll factor the other two terms. So what that's going to look like, guys, is the x cubed has a GCF of x cubed plus x squared has a GCF of x squared, and that factors into x squared times x plus 1. Then the negative 4x minus 4 has a GCF of negative 4 since they're both negative, but then we need x plus 1 in parentheses because that's how we get negative 4x minus 4 in green. And that's how we get x cubed plus x squared in blue. And it's all just equal to 0. Now, guys, the x plus 1 is a GCF. Because think about it, what if the if we replace x plus 1 with the letter, let's say u, I'm just pick up a random letter besides y, then it would become x squared u minus 4u, and it would factor into u as the GCF times x squared minus 4, right? So the u is equal to x plus 1, so we'll replace u, not u, but the letter u. U will be replaced with x plus 1 times x squared minus 4, right? That's if you have a hard time factor by grouping, right? This is our GCF. So it becomes x plus 1 times x squared minus 4, which is what I said equal to u, is equal to 0. Now, we could factor the x squared minus 4 farther, but what I'll do is I'll just, actually I will do that. So I'm going to get x plus 1. The x squared minus 4 is a difference of squares that'll factor into x minus 2, and x plus 2 equals 0. If I set x plus 1 equals 0 and solve, again, you don't have to show this step, you'll end up with x, so I'll just put an arrow. Let me fix that. You'll end up with x equals negative 1 is one of the zeros. If x minus 2 equals 0, you add 2 on both sides, you get x equals positive 2 as another 0. And if x plus 2 equals 0, you subtract 2 on both sides, you get x equals negative 2. So these are the zeros. The zeros are, I'll put them in order from least to greatest. So negative 2 is the lowest, then negative 1, and 2 is the highest. So these are our roots, or our zeros, okay? And they're also the x-intercepts of the graph. This last value, the negative 4, the constant term, is our y-intercept. So you'll see what I was talking about that in a second. So find algebraically the zeros for p of x. We did. They're positive and negative 2 and negative 1 for the x values. So let's graph those. Those are the x-intercepts. We have negative 2, negative 1, and positive 2. And then the y-intercept should be negative 4. So negative 1, 2, 3, negative 4 is our y-intercept. And I'll make sure these points are nice and thick so that when we graph, they still show. Okay, now guys, the reason I did that first, you didn't have to do that first, is that it'll show you when you, if we'll know if we made an error in our previous questions now that if the points don't match here. So let's go into the graphing calculator, right? So we want to use our graphing calculator, and I'm going to set my window so that the x values go from negative 10 to 10, and so do the y values, and we'll see if the graph fits, and use a step of 1, and you should know how to do that in your calculator, all right? So you might have to use y in your calculator, but I could use p of x, fortunately. So it was x cubed plus x squared minus 4x minus 4. So let's check that we got the correct roots. Remember, it was -2, -1, and +2. So we did get those correctly. So our answer to the first part was correct. The next thing we want to check is our y-intercept. Was -4. Let me get this out of the way. I don't know why, like what I did here. I messed it up again. I don't know how I did that. I'm going to set it from -15 to +15 so that in case I accidentally make the graph smaller. All right, and we could do this from -11 to +11. I don't know like how I'm deciding to do this. I'm just trying to make sure everything that we could see everything, right? So our y-intercept is -4. We already confirmed we got the correct roots, and our y-intercept is also correct at -4 right here. 1, 2, 3, 4. So we do have we know we're fully correct in the first part of the question, and we got the correct points so far. We got 4 of the points so far, 3 x-intercepts and 1 y-intercept, all right? So that we don't need to worry about. The next thing you want to do is you want to know how to find the relative minimum and maximum values of the graph, because those won't show in the table depending on the scale you're using. So the relative maximum or turning point, one of them is -1.5 to the nearest 10th, because we can't graph more accurate than that. So -1.5 and 0.9 is the y value. So that's going to be, if this is -1 and -2, -1.5 is halfway, and that's about 0.9, right? Just under 1, right? So this is, and here we'd have y equals 2 just to label the graph, right? And here we have y equals, let's say, 4. This is 1, 2, 3, 4. Okay, so -1.5 and +0.9. -1.5 and +0.9 is right there. Okay, so we got that -1.5 and +0.9. Now the other turning point is +0.9 and about -6.1. So +0.9 about -6.1. So +0.9 is just before the number 1, and then 1, 2, 3, 4, 5, 6.1. It'll be like here, so +0.9, -6.1. All right, so now we got our 2 turning points. Now all we need to do is use the table, okay? So you didn't have to graph the x and y intercepts first, but you want to get the turning points. But the x and y intercepts just make sure that especially the x intercepts, help make sure we did the previous part correctly when we're doing algebraically, when we're solving for the zeros. So now let's just get the table and we could get all the points. All right, but you had to get the turning points first, otherwise you would not have gotten full credit. So let's say we start at -5. See, that's already too high. -4, but -3 works, right? I'm just going to continue and go up until, all right, so already it went too high, right? So let's get these points in. So we got -3, -10, -2, 0. So -3, -10, -2, 0. So we got -3, -10. So this is going by 1. So 1, 2, 3, 4, 5. This is -5. -6, 7, 8, 9, 10. So it was -3 and -10. So it's all the way down to the bottom of the graph. So I'll get that. And then -2, 0 was the other point. So we know that was good because we calculated properly. See how the next one's -1, 0? We needed to get the relative maximum to know what goes in between. All right, and that's how we got that. Then of course we have the y-intercept at 0, -4, which we got right here. Then we got 1, -6, but if we didn't look for the relative minimum, we would have missed this point. All right, so let me make sure I just connect this nice and neat. And this graph doesn't have to be perfect. All right, so let's connect what we got so far. It helps to do it in parts and pieces. Unless like you're really good. I know I need like, especially on the computer, I need a little more like. All right, and I'll connect what we got so far. So it went to 2, 0. All right, so we got these points right here. Okay, and then we also want to connect this one. It's what I like to do. You don't have to do this. I like to add some points in between just to help me kind of guide me as I get my points. So if it's -3, -10, I'll just add, let's say, -2.5 in between, just so I could have an extra point that I can kind of use to guide me. So negative 1, 2.5, 1, 2, 3.75 is about right here. So now it'll be easier for me to kind of connect the points as opposed to like struggling to stay between the lines like this. Right? So now I know kind of how to guide it so I get a nice neat graph. All right. And then I'll also want to get, I'll want to make sure this point's showing. I'll put the arrow over here. All right. And then I want to see how the graph increases after the next root. So we got 0, -4, 1, -6 is right here. We got 2, 0. Then we got 320, but that's obviously not going to fit based on the scale we use. So let's say if we use 2.5, it's about 7.9. So 2.5 goes to about 7.9. I don't think you have to go this much in detail, but 2.5 will be here. 1, 2, 3, 4, 5, 6, 7.9. I think if we just show the graph going up this way, right? I don't think we even had to go all the way up there. That's enough. All right, and this was the graph of y equals p of x. I'm making sure I got arrows on both sides, and I'll label this -3. So 0, -1, -2, -3. Or I'll just erase it. There we go. So that's our graph, guys. It said to graph y equals p of x, so that's why I labeled the equation on the set of x's below, and we did. So the main thing you got to remember, guys, to get the turning points, right? Make sure you got the correct roots and y-intercept, and then the other points, get the other points and graph, right, using the table. All right, so again, it's the zeros and y-intercept, in other words, the x and y-intercepts, the turning points, and then just use the table of values and graph, all right? And that was all there was to it. So find the zeros algebraically, which we did, and then graph y equals p of x on the set of x's below. All right, that's all there was to it, guys. That would be a full 4-point response. All right, ready for the next question? 33 is done. 34, one of the medical uses of iodine 131, which is I-131, a radioactive isotope of iodine is to enhance X-ray images, so I-131. The half-life of I-131 is the same thing, I-131. So the half-life of I-131 is approximately 8.02 days. A patient is injected with 20 milligrams of I-131. Determine to the nearest day, that's the nearest whole number, the amount of time needed before the amount of I-131 in the patient's body is approximately 7 milligrams. Okay, so I'm going to do this algebraically, even though it didn't say to, because I'm not sure what they were looking for. So if I want the amount of I-131, I'll just say that. After D days, remember, half-life means it's decreasing by a factor of 1/2 or 0.5, right? The initial amount is 20 milligrams. So the amount after D days will be 20 times 1/2 or 0.5. I'll put 0.5, or you could even put 0.50. It's to say it decreases by 50% every 8.02 days. But it's not to the D power because it's once every 8.02 days. I'm sorry, there was no decimal there. So it decreases by 50% or by half its mass it loses every 8.02 days. So that's why I put this in the denominator, right? So the half-life comes in the denominator of the exponent. And they want to know to the nearest day, nearest whole number, the amount of time needed, that's D, right, before it's equal to 7. So if I set the equation equal to 7, I'm not even going to put the 0 in front because it's not necessary. But I do have to put the 8 in front of the decimal here. We want to know how long it'll take to be 7 milligrams. And I'll do this algebraically. First thing let's do is let's divide both sides by 20, right? And I like to keep them as decimals. So these cancel, and I'm going to get 0.5 to the D over 8.02 is equal to 7 over 20, which we could just quickly get in our calculator, is 0.35. All right? Or we could have left it as 7 over 20. Doesn't really matter. Now what I'm going to do is you could use the common log, or you could use the natural log on both sides, but I like to use the log with the same base. So our base is 0.5. So our exponent is d over 8.02 is equal to, you remember how to write logarithms using the same base? Log of base 0.5 of what we want it to equal, 0.35. Putting the zeros in front if you choose to, I chose not to. Now, I like to just calculate everything before I round. So I multiply both sides by 8.02, and the 8.02 will come in front here, times log of 0.5 of 0.35 or something of that nature, right? You could have also used the natural log on both sides or common log, but I find this simplest. And remember they said to find to the nearest day the amount of time? So I'm going to just put this in the calculator now. Oops. And I don't need the graph. All I need now is I need to use a function, miscellaneous, and I want to use log with chosen base, not the natural log or common log. You could have, but then you'd have to do it on both sides. I'm doing with the base we chose. So it was log 0.5 of 0.35, but we multiplied by 8.02. The problem is if we round too early, we might miss out on some value. So to the nearest, this is about 12.147 days, right? So D is about 12.147. So now to the nearest day, that's about 12 days, right? So that's our final answer. Okay, let's make sure we answered every part. So one of the medical use of I-131 is to blah, blah, blah. Half-life is 8.02 days. A patient is injected with 20 milligrams. Determine to the nearest day, the amount of time needed before the amount of I-131 is approximately 7 milligrams. So to the nearest day, it was about 12 days before the amount in the patient's body was 7 milligrams. Okay, and that was it, guys. It was just knowing how to interpret half-life, solve exponential equations using logarithms. If you use the common log or natural log on both sides, that's equally correct, all right? But that's what it was about. I'm trying to keep myself here when I can, all right? Let's move along, guys. I don't want this video to drag on. If you don't know this, what you want to look up is half-life, solving exponential equations using logarithms, all right? So let's move along. Solve the equation square root of 2x minus 7 plus x equals 5 algebraically and justify the solution set. So there are two parts. We got to solve it algebraically, then justify the solution set. First thing I'm going to start off doing, guys, is subtracting x on both sides. And I'll get square root of 2x minus 7 is equal to 5 minus x after I subtracted x on both sides, or negative x plus 5, right? Now how do I get rid of the square root? I have to square both sides. And what that gives me, guys, is square root and square cancel out, so all I'm left with is 2x minus 7. And when I square a binomial, if you know the shortcut, rather than having to do it by hand like this, rather than having to do it by hand like that, if you want to do it that way, you can do that, but that's a lot of work. Instead, first you just square the first term, you multiply the two terms, right? And you get negative 5x, but you double the product and it's negative 10x. You square the negative x, it becomes x squared. If you did it here, you would have gotten the same thing. If I distribute the 5, I get 25 minus 5x. Distribute negative x, I get negative 5x plus x squared, which negative 5x minus 5x is negative 10x, which is what leads us to this, okay? So now what I'm going to do is, I'm going to add 7 to both sides. And I'm also going to subtract 2x. So that I set the left-hand side equal to 0. And it becomes 32 minus 12x plus x squared when I combine the like terms. So 32, 25 plus 7 is 32. Negative 10 minus 2x is negative 12x. And x squared just comes down. So I'm going to rewrite in standard form, and I'll put the x on this side. X squared is the first term, minus 12x, and positive 32. So I'm just rewriting in standard form. I didn't use inverse operations or anything. I'm rewriting in standard form. I'm just changing the equation so the zero is on this side. So the two fastest ways, at least in my opinion, to solve this instead of the quadratic form is either factor or use complete in the square. I think factoring will be faster because two numbers that multiply to 32 and also sum to negative 12, they both have to be negative, right? To multiply to a positive 32. Well, 8 and 4 will give me 32 when multiplied. If they're both negative, they'll be positive 32. Negative 8 times negative 4 is 32. And if I do negative 8 minus 4, I get negative 12. So it's just x minus 8 and x minus 4 equals 0. If I solve x minus 8 equals 0, I get x equals 8. If I solve x minus 4 equals 0, I get x equals 4, right? Now, I need more space. I was just putting this to illustrate that you didn't have to do that part because I want to be able to continue. So it said to solve the equation, which we kind of did, but we didn't because remember, you have to check for extraneous roots using your calculator if nothing else. So justify the solution set. So solve the equation and justify the solution set. So justifying the solution set is a part of solving the equation. So using the original equation, square root of 2x minus 7 plus x equals 5. So I'll write the equation again over here. Square root of 2x plus 7, minus 7, and then plus x equals 5. So I like to just use the original equation because the more manipulations you do, because in its truest form, a solution needs to solve the original equation, right? So I'll just substitute 2 times 8 minus 7, right? Substituting 8 for x, plus 8 equals 5. 2 times 8 is 16 in the parentheses, in the square root sign, and 16 minus 7 is 9. Now, already I know that if I'm adding 8, the square root of 9 is 3, and 3 plus 8 is not 5, it's 11. So we have to reject x equals 8. So that's an extraneous root, a root that didn't work, because when we squared on both sides, that introduces, it could introduce one or two extraneous roots, and sometimes it doesn't introduce any. But in this case, it introduced at least one. So now let's check for x equals 4, right? So the square root, same thing, of 2 times 4, when I substitute 4 for x, minus 7, plus 4 equals 5. 2 times 4 is 8 minus 7 is 1 in the parentheses, in the square root sign. So we get square root of 1 plus 4 equals 5. The square root of 1 is just 1. 1 plus 4 is indeed 5. And if we simplify all the way, we get 5 equals 5. So x equals 4 is a solution. It's the only solution to this equation. And we could have also confirmed in our calculator. All right, but that's our answer. So solve the equation algebraically, which we did, and justify the solution set, which we also did, okay? So let's make sure we could get this all in the screen. Hopefully it's not too small. And it was a lot of writing. I kind of took up the whole page. All right, so this is the bulk of what we need right here. And I guess I could come up here too. I hate that fact that the screen is getting scrunched so much. I want to see if I could zoom in or something. Oh, not this one. Sorry. That's not what I meant to do. I'm going to minimize me again and see if I could fit this to screen. One note. All right, and I'll enter full screen and see if that helps. That might help, guys. All right, so here's what we got. Solve the equation algebraically. The original equation was this one right here, square root of 2x minus 7 plus x equals 5. So it had two steps. One was to solve algebraically, and the other one was to justify the solution set. And we did both. All right, so moving along. We're going to go to question 36 now. Last one, guys, in this video. Okay. I don't know if when I entered full screen, if that blocked the video from showing part of it. I just realized because I selected parts of the screen to show in the video, so I hope it didn't block out. If it does, I'll see if I need to change anything. So I could come up for now. All right. So Avia designed an experiment. Let me get the highlighter. To determine the effect of a new energy drink. So remember, an experiment is always used to determine cause and effect relationship. So the effect of a new energy drink on a group of 20 volunteer students. So guys, before we even move forward, remember in an experiment, you always have two groups, right? The person randomly divides participants into two groups. One is the treatment group or experimental group that receives treatment, and then control group to compare with that has no treatment. All right, and here the treatment is the energy drink. I gotta minimize me. So she wanted to determine the effect of the energy drink treatment, okay, on a group of 20 volunteer students. So she's gonna split them into two groups of 10. So 10 students, so I'll use a different color now to highlight this part. The 10 students were randomly selected to form group 1. So that's group 1 right here. All right, while the remaining 10 made up group 2. That's right here. Okay, so each student in group 1 drank one energy drink. That's the treatment group or experimental group. So group 1 was the energy drink or treatment, and group 2 drank a cola drink, which is kind of like if you're taking a medication, one group would take the medication and the other one takes a placebo, which is just um, another tablet. It's basically a sugar pill. It doesn't have any medication in it, but it could have a psychological effect, right? So group 1 got the treatment, which was the energy drink, and group 2 is the control group. They just drank a cola. So this is the control group, because you always need a control group, and this is the treatment or experimental group. All right, so each student in group 2 drank a cola drink. 10 minutes later, back to yellow, their times were recorded for reading the same paragraph of a novel. It's very important that it's the same paragraph, guys, because if it was a different paragraph, then that's not fair, because someone could be reading a different material and it could take different times to read different materials, right? So they all had 10 minutes to read the same paragraph, and the results of their times were recorded. The results of the experiment were shown below. So basically, we want to see if if the energy drink causes people to read faster. So here we have the times for people on the left-hand column. These are the different times for people in group 1 who drank the energy drink, and the mean at the bottom is 17.7 seconds. That's the average reading time. For group 2, when they drank the cola drink without the treatment, then they had the reading times in the right-hand column, and their mean reading time was a little bit longer at 19.1 seconds. So in the energy drink group, they read faster because they took less time to read compared to people who drank the cola, right? So Avia thinks that energy drinks make students read faster, probably because she's looking at the mean reading times and seeing that the reading time was faster or less for the people in group 1 who drank the energy drink compared to the group 2 that only drank cola. Using information from the experimental design or the results, explain why her hypothesis may be incorrect. So I want to look at the results first. Let's see if there are people in group 2 who actually read faster than group 1. So here we see the group on the right hand side. I see a 12.7 seconds here really stands out because there's nobody in group 1 who read that fast, right? All the reading times were faster than 12.7 seconds. I see a 14.5 and 17.4, 18, 19, 18, 16, 16, 15, 17, 19. Nobody read that fast in the energy drink group either. The two fastest readers are from group 2, so that already proves that her hypothesis may be incorrect. But besides that, 16.3, even though it's not faster than everyone in group 1, it's faster than a lot of people in group 1, like the one who read 17.4, 18.1, 18.2. It's faster than almost everybody in group 1 besides maybe 2 of the students. 18.8 is slower than most students in group 1, but there were students in group 1 who read slower than 18.8 seconds. So we got 1, 2, 3, 4. Then we got 16.9, which is faster than almost all the students in group 1 besides maybe like a handful, right? So there are 1, 2, 3, 4, 5 students in group 2 who read faster than students in group 1. At least that read faster than some of them, and 2 that read faster than all of them, right? The rest of them took extra long to read, so we don't know for sure that it's because of the energy drink, or was it just because of the randomly who was put in each group, right? So Avia's hypothesis may be incorrect simply because there were students, was it students, right? Yeah, students. There were students in group 2, which was the cola drink, that read faster than students in group 1. That's basically what it comes down to, who drank the energy drink, right? Group 2 was the cola drink. So if there were students in group 2 who actually read faster, if there were students in group 2 who actually read faster than students in group 1, Avia's hypothesis may be incorrect because she thinks drinking energy drinks made them read faster. But based on the results, it was using information from the results, Avia's hypothesis may be incorrect because, again, there were students in group 2, the cola group, that read faster than students in group 1, the energy drink group. That's all there was to it, guys. It doesn't mean that she's definitely incorrect, but we don't know for a fact. So let's go to the next part of the question. Using the given results, meaning the results from the table, okay? Avia randomly mixes the 20 reading times. So she randomly mixes the 20 reading times. Let me get that again. What did I just do? She randomly mixes the 20 reading times, right? Because there were 10 from group 1 and 10 from group 2. So she scrambled them up, split them into two new groups of 10, right? So she mixed them up, split them into two new groups of 10 randomly, right? And simulates the difference of mean 232 times. So if I take these times, right, from group 1 and group 2 and mix them up, what that does is that means that there are students in both groups who drank both cola and energy drink. So if there was an effect of the energy drink, that takes that effect away, right? That's why this simulation is useful. And she did that 232 times. So if you were to add up, like this is 2 times, 1 time, if you were to add all these up, they would add to 232. So that's also important. So the difference of means, and it says group 1 minus group 2. So group 1, which was 17.7 seconds, and group 2, 19.1 seconds, right? So let's find out what the actual difference in means was first. So I don't have space to do it here. So I'll just write here mean for group 1 minus, or there's a symbol, guys, for sample mean. I'll rather do that because we're taking a sample. X with a bar on top means the mean for a sample. This is a population mean, the mu, but we're taking a sample mean. So the sample mean for group 1, I'll just call x1, minus sample mean for x2 was simply 17.7 minus 19.1. And it was in seconds. So if I do that, 17.7 minus 19.1 is negative 1.4. This means that in the observed difference, right? That's what happened when Avia did her experiment. The average reading time for students in group 1 was 1.4 seconds less than students in group 2, or they read 1.4 seconds faster than students in group 2. So let's see what let's see what part B is asking us now. Avia has decided that the difference in mean reading times, which was negative 1.4 seconds, is not an unusual occurrence. Support her decision using the results of the simulation. Explain your reasoning. So guys, this is all about statistical significance. So if it's not unusual, that means that it happened frequently enough in the simulation without the effect of the treatment that we don't have enough evidence to conclude that the energy drink is what caused group 1 to read faster, and it could happen just by chance alone, just by randomly splitting any people into two groups, whether they get treatment or not. So statistically significant would have meant that it was rare, it was an unusual occurrence in the simulation, so it had to be due to the treatment. So if I look carefully, guys, at the simulation results, here I got -1 between the bars, right? And it goes to -1.6 here. So this is -1.1, 2, 3, 4. So -1.4 starts here. What I want to look at, guys, is how many times did students in group 1 read 1.4 seconds faster, or even more extreme than that, meaning they read 2 seconds faster. Their mean reading time was 2 seconds less or 3 seconds less, right? So we're going to look to the left-hand side, because -1.4 seconds means they read 1.4 seconds faster. -2.2 seconds means they read 2.2 seconds faster, because they took 2.2 seconds less. So these are the ones that have a mean reading time where the difference is 1.4 seconds faster, or even more faster, even though I'm not supposed to say more faster, or more seconds faster, right? The difference is even greater, even though I'm going towards the negative end, right? The difference is the gap is wider, where group 1's speed was faster and faster compared to group 2. So let's add these values up. Here we got, so I'm just gonna take this part out, and we got that boundary where we're gonna end at, right? So this is 1 plus 2, 3, and then we got 2 more. 3 plus 2 is 5. So I'll just write 5 now. Let's just do this. So we got 1, 2, 3, plus 2 more, 5, plus 5, 10, right? Plus 2, that's 4. 14, plus 3, 17, plus 2, 19, plus 1, 20, plus 2, 22, plus 3, 25. So 25 times we saw that mean reading time was -1. The difference in means when you do group 1 minus group 2 was -1.4 or less, right? So from on this side of the graph, 25, and remember it was simulated 232 times. So 25 out of 232 simulations, right? We want to convert that to percentages. It's about 10.78%, all right? To be unusual, if it happened less than 5% or less of the time, that's unusual. We don't expect it to happen by random chance, by just randomly splitting people into two groups. That's statistically significant. So if it happened less than 5% of the time in the simulation, that means it's unlikely to happen to random chance alone. It's unusual, and most likely it's due to the treatment, which was the energy drink. And then you could say, okay, more than likely energy drinks cause students to read faster. So, and the less frequently it happened, the more likely it's due to the energy drink. So starting at 5%, as you get down to 2%, 1%, the more we are leaning towards saying it's more likely due to the energy drink, right? But more than 5% is not statistically significant. 10.78%, while it's not like happening all the time, it's not unusual. We could expect that difference to be seen every so often uh, by just randomly splitting people into two random groups without an energy drink, cola, nothing, and just recording their reading times. About almost 11% of the time, 10.8, 10.78% of the time, we could expect to see a difference of means where group 1 reads 1.4 seconds faster than group 2, all right? So Avia decided that her difference in mean reading times is not an unusual occurrence. Support her decision. So using the results of the simulation. So the observed, that's just what we saw, right? Difference of -1. I'm sorry, let's fix this. So we'll just say, let's put a full sentence, all right? So the observed difference was -1.4 seconds, right? And if we want to be precise, we'll say the observed difference in mean reading times. All right, I don't want to have you lose points, so I always like to put as much as possible. I know it's a little extra effort, but I just like to kind of play it safe. So the observed difference in mean If we say that the observed difference in means is fine, right? Group 1, we don't have to say that. We already showed that it was group 1 minus group 2. So the observed difference in means was negative 1.4 seconds. And we'll just say that in the simulation, because they want us to base on simulation, right? A difference of negative 1.4 seconds or lower occurred 25 out of 232 times, or about, it was about 10.78% or 11% of the time. We could have just said about 11%, right? That means the difference in mean reading times is not an unusual occurrence. I'll just say the difference is not unusual. All right, it's most likely due to the random assignment of people to two groups and has nothing to do with the treatment, more than likely. That's what they really mean. It's not statistically significant. Now, had the difference been positive, we would have looked, so let's say the difference was positive 1.4, we would have looked to the right-hand side, right? But since it was, we would have looked to the right-hand side instead, like this, to see which one is that much or greater. But since it was negative, the difference is actually more spread apart if we look at uh, moving to the left, right? Um, make sure you understand that, okay? So this is all about difference in sample means and statistical significance. I highly recommend a website called mathbits.com. Mathbits Common Core Algebra 2 website covers this topic of difference in sample means, okay? And if you could do those, this will be a joke, not a joke, but this will be a lot easier. All right? So the first part of the question, part A, why might obvious hypothesis be incorrect? Her hypothesis may be incorrect because there were students in group 2. There were students in group 2 that read faster than students in group 1. Right? That was all there was for the part A as to why her hypothesis may be incorrect, again, because there were students in group 2 that read faster than students in group 1. Then Avia decided the difference in mean reading times is not an unusual occurrence. Support her decision using the results of the simulation. Explain your reasoning. So the observed difference in means was negative 1.4 seconds, and in the simulation, that difference of negative 1.4 seconds or lower occurred 25 out of 232 times, or about 10.78% of the time. Meaning the group 1's reading time was 1.4 seconds lower, or even farther below those in group 2. So in the simulation, a difference of negative 1.4 seconds or lower occurred 25 out of 232 times, or about 11% of the time. I'm just rounding now. That means the difference is not unusual. So once again, the observed difference in means was negative 1.4 seconds. In the simulation, a difference of negative 1.4 seconds or lower occurred 25 out of 232 times, or about 10.78% of the time. That means the difference is not unusual. All right, that's all there was to it, guys. We supported her decisions using the result of the simulation, and we explained in depth. So guys, that was it for 36. I'm going to come back in a second to do 37 in the next video, but thanks for stopping by. I applaud you for, honestly, in all honesty, right, from the bottom of my heart, for taking the effort to go through this. And you know, you don't have to go through every question. If the video is too long, I apologize, but just the ones that you need the help with, right? That's why I go into a little bit of depth. So fast forward, rewind the video. If there's something you understand, you don't need to go through it, right? Unless you want to do it for entertainment, but I'm sure you got better things to do, right? If it really go through the parts where like you need to, where you want to review stuff and want to make sure you understand it in depth, okay? That's why if the video is too long, that's why. Okay, but just go through the ones you need to. You don't have to go through everything, all right? So best of luck, guys. If you enjoyed the video, please hit like, subscribe, and I know you'll do great. All right, bye for now.